Hello, everyone. Am I audible? Can you hear me? If you can, put your thumbs up. Okay. Yeah, that's fine. What we did in the last class? Shall we wait for some more time or shall we start? Okay. Any of your friends still left or shall we start? Okay. How are you all? Solving questions? Did you solve questions at home? Okay, so we did till De Morgan's law, na? Okay. Now first we'll move to Venn diagrams. Okay, Venn diagrams are something interesting that you may have seen it earlier also. And then we'll be doing the questions related to this chapter that are important, and the rest of the concepts that will be completing for this particular chapter, right? So we'll be starting today with Venn diagrams. Venn diagrams, right? Anybody know what is Venn diagram? You all must have seen it earlier. Where was that boy who answered last class? Is he not present today? Oh, that's it. That's it. I got it. Pardon?
Pictorial representation of a data, sir.
Exactly. Venn diagram is kind of pictorial representation, but not exactly. Basically, what we do here, whatever the operations we did on this unions and intersection, we can do it in graphs also. Okay, not exactly graphs. These are representation kind of thing where we represent the datas. Okay, in diagrammatic form. So that is Venn diagram. You have seen these questions earlier when you used to give that logical reasoning test. So there they used to ask such type of questions. Okay, for example, if I'm writing a set A and a set B. So what is happening here? What is happening here? See carefully. See here. These are very much important and very much easy. If you get this, you'll get full marks on it. See, let us say this is a universal set. Universal set. For example, if I'm writing X is a set belonging to N. What is N? Natural numbers. So X is a set of natural numbers, but X should be less than equals to 4. So how many elements will be there? How many elements will be there?
4, sir.
4 elements will be there, right? But see here, if I take a box, this box represents U. U is in universal set. Universal set, let us say that it contains everything. In those everything, we have a set A, okay, that is containing 1, 2, 3, and 4, right? Understood? In universal set means what? Everything in the universe is universal set. Whatever the composition of everything in the universe is comes under universal set. So in that universal set, we must be having 1, 2, 3, 4 also, and that is being contained by A. So this circle represents this set A, which is of X, such that X belongs to X is less than equals to 4. Understood? I should write it like this: X such that X belongs to N and X is less than equals to 4. Right? So this is the set A. Now if I write a set B, of Y such that Y belongs to N and Y is less than equals to 4, greater than equals to 4 and less than equals to 7. So how many elements will be there? How many elements? 4 elements only. 4, 5, 6, 7. Because 4 you have to contain, 7 you have to contain. Okay. So I'll draw another element set B. I'll draw another element set B like this. That will contain 4, 5, 6. That will contain 4, 5, 6, and 7. Now see here, 4 is an element that is present in both of the conditions, na? Both A and B. Agree? 4 is an element that is contained by both of them. So this is what, if I say, what is A intersection B? What is A intersection B? 4. 4. Okay. What is A union B? 1, 2, 3, 4, 5, 6. So it will be all of the 1 to 7. 4, 5, 6, 7. So this will be A union B. Right? Agree everyone?
Yes,
Put a
sir.
thumbs up if you understood. So what is happening here? This was an example. So if I say like this, that I have a universal set U that contains 2 different sets inside it. Okay, this is set A, this is set B. So can I say that this middle part shows that A intersection B, whatever there will be, it will come under A intersection B? Yes or no?
Yes, sir.
Right? Now, whatever is there inside this circle, this whole will contain A union B. Right? Whatever is there inside the circle will contain A union B. Agree or not?
Yes,
But the
sir.
thing is that, see here, what is A union B? If I ask you, what is A union B? A union B. So you say, sir, N of A, number of elements of A union B will be N of A plus N of B. But while adding A and B, you will add this A intersection B twice, isn't it? Imagine that. While adding A and B, you take this card A, you take this card B. But here you have overlapped it. So while adding A and B, you will add this part twice. This part will come under A also and B also, isn't it? So that's why we do what we do next. So I subtract A intersection B from this. So this is the formula for A union B. A union B is NA plus NB minus NA intersection B. Understood or not?
Yes, sir.
Understood? So this is the concept. Why? What happened here? You added this common portion twice while adding NA and NB. So this portion got added in both of them. So that's why what we did, to get all of the components of A and B, we subtracted this A intersection B part once. Got it? So this is A intersection B, sorry, A union B, the total number of elements in A union B. This is how we do it. Next thing, right? Now tell me, if we have a set it like there, this is set A, this is set B. Can you tell me what this part shows? You have studied A minus B, you have studied B minus A, you have studied subtraction, addition, union, intersection, everything. I hope you would have revised also. I don't know. Have you revised? Everyone? Put a thumbs up. Everyone? There are still people who have not revised. That is not good. Can you tell me how can we like represent this portion which I have shaded?
A complement.
Pardon?
A complement.
A complement. So if you just say A complement, that will include this unshaded, this portion also, the universal shade like area also. But I just want this. If you will say A complement, that means everything except A. So except this is A part, everything except A will come. This universal set will also be there. But I just want this.
B minus A.
A minus?
B minus A.
B minus A. That is correct. Very good. That means you have revised. What was the name? I forgot it. What was the name? I forgot your name.
It's not sir.
Pardon?
It's not sir.
Okay. So it is B minus A. That is correct. B minus A. Understood, everyone? Because we have to contain all the elements of B, but whatever is there, if in common with B, we don't want that. Understood? That's why we wrote B minus A. Because I want all the elements of B, but I don't want those elements which are common with A. These were the elements which are common with A. So I will write B minus A. In the same way, how will I write this part? How will I write this part? Be loud.
A minus B.
A minus B. Very good. It will be A minus B. Understood? And the middle part will be A intersection B. Got it?
Yes, sir.
Good. Can you comment on this set? What kind of set is this? This is set A, this is set B. This is set A, this is set B. What is A intersection B? Tell me. What is null set? Very good. A intersection B is null set. And what kind of sets do we call for this? Is there any specific name for this? Any specific name?
Disjoint set.
Disjoint set. Very good. Disjoint sets. Is there only one boy who study maths here? Please revise everything. If you will not revise, you won't get anything in the like next class. Everything is relatable. Okay, I'll complete this chapter by today. I hope so. And from on the next class, I'll be having a question session on this particular chapter. So what I want from you all of you, those who are looking outside also, at the back, girls there. So please listen here and concentrate. Otherwise, you won't get anything. And revise at home. Written this page, you write it down. If everyone has written, just let me know. I'll move forward.
Completed, sir.
Okay. Okay. So this was a part of it, right? Now, if I draw something like this, this is set A, this is set B, this is universal set. Can you comment on A and B? What is A intersection B? What is A intersection B here? Yeah, you are correct. Say it louder.
B, sir.
B. Because what is there in common with A and B? That is B part only. Whole B is inscribed in A. So this will be B. That will be common in both of them. So what kind of set is it? Can you comment on it? Can you comment on it?
No, sir.
So B is a subset equal to A. Isn't it? B is a subset of A, right? Because B has been taken every of its elements from A only. Understood? So let me give you one question then. Try to solve this question. We have a set like this. This is 1, 5. This is 3 and 7. Three and 7 here. And in the universal set, we have 2, 4, 6, 8. So you have to find A union B, A intersection B, then A minus B, and A complement. I'll ask you, don't answer randomly. I'll ask each one of you to solve this. All of you have to solve all of these questions. I'll ask randomly. Done, everyone? Okay, good. The boy next to you. What was that name? I'm still forgetting. Yeah, the same boy. We'll answer the first question. Try to answer this. Be louder. Please convey that message. I cannot hear him.
1357, sir.
1357. Can you name this set? Like as this girl said that A intersection B is B itself. So can you name this set A union B? This is A only. You can see that all of the elements of this particular set that you have framed A union B is there in set A. This is set A, this is set B. So all of this is in set A. Understood? Okay, the last venture. No, I can see his face straight to you. From your left hand side, move back. From your left side, yeah. Last venture, there. No. The straight one. Yeah, that one. Yeah. Tell this answer. A intersection B. Please convey that message. How much?
3, 7, sir.
3 and 7 now.
He said only 3, sir.
He said only 3. Why? Why 7 won't be there? Isn't 7 common in both of the sets? Try to focus here, otherwise you won't get anything. Isn't 7 common in both of the sets? 7 is there in A also, 7 is there in B also. So 7 will also be common now.
3 and 7.
3 and 7 will be the answer. Okay? You may sit down. Okay, the girl sitting left to you, having specs. Yeah, what is A minus B? 1, 5. Yeah, that's correct. Okay, and the girl at just the back of you. Yeah. A complement. What is A complement?
2, 4, 6, 8.
How much?
2, 4, 6, 8.
So 2, 4, 6, and 8. That is correct. Good. So understood everyone? Yes or no? Put your thumbs up. Good, good. Try to be here. Try to be attentive. You have time to play. I am not asking you to study all of your time, 10 hours, 12 hours, not like that. Just study 5 hours. That is enough, but consistently every day. And focus on during the classes. If you focus here, you would get 90% of it in your brain. Otherwise, you'll have to revise it for 10 times and you won't get anything. Right? Okay, next question. Next question. Okay, we'll start with a simple one. Okay, before that, I need to teach you one thing. See here, we learned about 2 sets in a Venn diagram, right? We learned about 2 sets in a Venn diagram. What if there are 3 sets? What if there are 3 sets? Right? So there are 3 sets. See here. See here. Everybody look here. This is very interesting. Let us say this is set A, this is set B, and this is set C. Right? And this is the universal set. Agree? Everybody is able to see? Any color problem? No, no. Okay. So this is set A, this is set B, this is set C. Everyone will answer. Tell me, what is this part? What is this part? An A intersection B. What is this part? N B intersection C. And what is this part? N A intersection C. And what is this part, the shaded part?
A intersection B intersection C.
Exactly. And A intersection B intersection C, that is common in all 3 of them. Now tell me, if I ask you, what is A union B union C? So you will say, sir, A union B union C. First of all, we have to add A. then you have to add B, then you have to add C, right? But while adding A, B, and C, do you think that you added this A intersection C, A intersection B, A, B intersection C twice? Do you think that?
Sir.
Sir.
Because see here, let us say that this is your set A and this is your set B. If they are overlapping, so this overlapping part got added twice now, isn't it? This A intersection C is available in A also and C also. Are you getting my point? If let us say that 4 is there, so you are adding 4 in A also, you are adding 4 in C also. So one time we have to subtract that now, isn't it? So I'll subtract n A intersection C once. Similarly, there will be 2 times n A intersection B and n A B intersection C. Agree everyone till here? Is there any problem? Is there any fault in this equation? Try to figure it out. There is some fault. There is some fault in this equation. Try to figure it out.
A intersection B intersection C.
You're correct, going correct. Find exact fault. Who found that will get a chocolate.
A intersection B intersection C.
What?
We did minus 30.
We have to subtract that. Like you are saying that we have to subtract this A intersection B intersection C once. That's what you are saying. Okay, see here. See here. What is happening? While subtracting A intersection C, A intersection B, B intersection C, you subtracted this common portion thrice. 3 times you subtracted it. Okay. And this got added 3 times in A intersection NA, NB, and NC. For example, see here. I'll give you a rough example. If this site contains element 2, this site contains element 2. Okay, everybody look up here. It is very interesting. If this site contains element 2, so if I'm writing NA, it will be there. Agree or not? If I'm writing NA, it will be there. If I'm writing NB, it will be there. If I'm writing NC, it will be there. Yes or no? Again, if I'm subtracting NA intersection C, again it will be subtracted once. In A intersection B, again it will be subtracted once, and in B intersection C, again it will be subtracted once. So we added it 3 times, we subtracted it 3 times. Now, is it there in the equation? So what we'll do, we'll add this A intersection B intersection C once. And now my equation is completed. Check this, everyone, and like let me know if you have got it or not. Understood the fault? Now I'll eat my chocolate myself. Got it? Write it down. So this is the formula for 3 sets. If you are having 3 sets in a row, so you can get the union from here. Written, everyone?
Yes, sir.
Good, good, good. Now let us move to solving questions. Okay. The question goes like, if A and B are two sets. A and B are two sets such that number of elements in A is 27, NB is 35, and NA union B is 50. You have to find and A intersection B. Let us solve this easy question. Could not hear you. If you are answering, be louder.
12, sir.
How much? 12. 12. Yeah, that's correct. 12 is correct. So everybody knows this. NA union B is what? NA plus NB minus NA intersection B. So from there, this was missing and rest all you knew. So from there, you can get it. Right? Shall we move on to the next question? Good. So next question is like, out of 600 cars investigated, 600 cars investigated, 500 owned. 500 owned BMW, 200 owned Mercedes, and there were few very rich people, 50 owned both of them. So you have to verify whether the given data is correct or not. You have to verify whether the given data is correct or not. Like the person you sent for this investigation. Huh?
The data is not correct.
Exactly. What's the fault here?
100 cars.
Okay, 600 cars. Okay. But the thing is that the total number of cars that was A union B that came about 500 plus 200 and minus A intersection B, that is 50. So it came about 650. So data is inconsistent. Data is given for 650 cars, but the investigation was done for 600 cars. That's why it is not correct. Not correct. Good. Third question. This you'll be liking. Who solved it first will get the champions badge. In a group of 52 persons. Group of 52 persons. 16 drink tea, but not coffee. 16 people are there who drink tea, but no coffee. And 33 drink tea. You have to find how many drink tea and coffee both? How many drink tea and coffee both? Second one. How many drink coffee? Try to write the question first, because when you'll revise this now, you'll get this. Otherwise, you'll just see the answer there, and that will be a difficulty for you. So first try to write the question and then answer. Try to solve this. This is not very hard. You just have to represent this. You may write in terms of Venn diagram, or you can do it with the logical operations also.
Now, sir.
Yeah, go on. Pardon?
In the question 33, drink tea, no, sir.
In the question?
33, drink tea, no, sir.
33, drink tea. Yeah.
Not coffee, no, sir.
No, nothing is given about that. Yeah, go on. Please, take your name again. I forgot it again.
First one, 17, sir.
First one you got is 17. Second one?
18.
How much?
18. 20.
Please convey that message. I could not hear him.
19, sir.
19. I won't say the answer. I need some more answers.
First one 33, sir.
First one 33. Second one? Can you come in front and tell me how you did that? That boy who did it earlier, 17 and 19. Yeah, can you come in front and tell me how you did that? Can you explain that? What is the procedure? Yeah. Okay, you did it with Venn diagram. Okay, I think. Yeah, right. Can you take a name now from here?
Can
Can you spell it out?
RASHANDL.
SHAND. Rishant. Rishant. Okay. I'll remember from now. Yeah, you're correct. This answer is correct. This answer is correct. Good. See how we did it. How we did it. So initially that thing was given that 52 persons are there. So we have a universal set of 52 persons. We can solve it like this also, and we can solve it the logical operation way also. Everybody look at the board. So this portion is what? This is A minus B. Or we can write it in tea and coffee in terms of tea and coffee. So this is tea minus coffee, and this is coffee minus tea, right? And this is coffee intersection tea, like the persons who are drinking both tea and coffee. So what were we given with? We were given with 16 drink tea, but not coffee. So this is the term, that is 16, right, everyone? 16 drink tea, but no coffee. 33 drink tea. So, and it was not given but no tea. So 33 drink tea, but no coffee. It was not given like this. Are you getting my point? tea minus coffee is 16. 33 constitute everything from here to here. This is 33. All of C. All of C is 33. Understood? So can you say that if I add T minus C plus C, T minus C, that is there, and plus C, or we can write it like this directly. See, A union B is what? This is not getting solved. 1 minute. Diagram is not correct. Yeah. So A union B is what? All of the coffee, all of the tea. That is 52. Agree?
Sir.
All of the coffee and all of the tea is 52. Now what else we are given with? We are given with A minus B. A is for tea, B is for coffee. A minus B, tea with no coffee. So that is 16. And Na, only tea, that is 33. Right? So if I say that, what is Na? What is Na? Can I write total number of Na as A minus B plus A intersection B? If you see the diagram, this portion is A minus B. And if I add the common one, can I get all of this A?
Yes, sir.
Right? That's what I did. Na is A minus B plus A intersection B. So A minus B was what? A minus B was 16. A intersection B was what? A intersection B, we don't know. All of A we know 33 plus A intersection B. From there we can get the intersection part. So A intersection B is what? 33 minus 16, that is 17. So first part of the answer is 17. Understood? He solved this. Rishant solved through Venn diagram, and this is the logical operation. Got it? Na is equals to A minus B and plus intersection part. From there you can get the whole of the set A. You have to imagine this. Second part that you have to see. If I'm writing an A union B, so I'll be writing it like Na plus NB plus minus N A intersection B. Agree? So what the portions do I have? I have this A intersection B part, 17. I have this Na part, that is 33. I have this union. All of the investigations occurred, that was 52. So from there I can get NB. From there I can get NB. NB is 36. If you calculate N of B, that total of only coffee drinking people are 36. But what the question was asked? Coffee but no tea. So we have to remove the common part. Agree?
Yes, sir.
For coffee but no tea, that is this portion. So this portion is what? So this is NB minus the common part, Na intersection B. Agree?
Yes, sir.
So that will be 36 minus, and intersection B is how much? 17. 17 now? Yeah. So that will be 19 answer. The second part. And this is the first part. Understood or not? Everyone put your thumbs up if you have understood. Okay, good, good. You have to solve more questions like this. There are n number of questions. You have to solve it like this. We'll be taking one questions class in the next session probably, or we'll be moving further. For that, you have to practice. I'll be giving one 3-set question in the next class. So till now, what you have to do, you just have to, you take this question instead to solve at home. I'll be just giving you this question to do it as homework. And this chapter is over, so you have to solve everything. Write this question. You have to do this as homework. And this chapter is over from my side. We'll solve some questions in the next class probably. And then we'll be moving on to the next chapter. I need doubts from your side also. No doubt means you're not solving any questions. I'll ask for the explanation also from all of you for this question if you have solved it. Written, everyone? Pardon?
5 minutes, sir.
Okay. Take your time. No problem. Any doubt as of now? Any questions that we solved today? That is NCERT book now that you are having?
Yes, sir.
Okay, so solve all the questions from that also. Start with NCERT and solve some other books also. Okay, only NCERT won't do. Maths and physics are subjects like you have to solve everything there. Every type of questions. Theories are very little and type of numericals are very much. Okay, see the examples, then go to the exercises and solve the miscellaneous also. Right?
Yes, sir.
Written. So this is a particular question from like you have to solve through the Venn diagram only, because it will be difficult to go through the logical operations. And this is of 3 sets. 3 sets are there. You see the formula, try to figure it out. Easy question is given, and we'll solve more questions on these 3 sets type in the next class, and then we'll be moving on to the next chapter. Right?
Yes, sir.
So shall we keep it for today if you don't have any doubt? At the last bench? Any doubt? Okay. Okay, then. That's it for today. Thank you.
Thank you, sir.